All right, let's start. Let's start with a lightning. Let's try to get your attention. Welcome back to Physics 112. Some announcement. First is your video survey is due tonight. It has been fun going through those videos. And tutorial for mastering physics is due on Sunday. If you have question about mastering physics, email the TA, email me. Please email your LAs, and then we'll try to figure out. The reason why I don't know the answer on top of my head, because when I log into those systems, I don't need any access code, so it's different. Any questions? Some announcements, your grade book. So last year, some students are not happy with the grade book, meaning, I guess by now you know, Canvas grade book is not accurate. Do you know that or not? Yeah. So like one person elevate that to the dean. So if you have a problem with that, you should talk to me. Right? You don't need to email Joe Biden. Like, it has come to my attention that Rizal Hariadi is an idiot. He doesn't know how to manage Canvas. You can email me. My plan is to email you your grade book every weekend. That includes the 90% correction for iClicker, 80% correction for perusal. You can ignore those things, fine. And I use a program that I had to hack. I write my own code. So I miss a few number of students. So I add a pause between students, like 10-second pause, like random amount of pause to trick Gmail. Let's see whether that thing is reliable or not. So, and then what else? No class on Monday and Wednesday, no in-person class on Wednesday. Office hours are listed here. They are tentative. Based on so basically we try to have office hours every work day. And then on the day that the homework is due, we try to put more than one. So there is like 4 hours of office hours in case you need somebody to help you before the homework is due. Okay. My office hour myself is on Tuesday because no one signed up for Tuesday. So I put my office hours on Tuesday. My office hours will not be in the building. So I run my lab in Biodesign Institute. So roughly here, my office is here, not outside, inside. But for non-regular office hours, sometimes I spend my time in my company, 20%. So this is in Phoenix downtown. And then just to all right. And then, sorry, you don't need to see me. So, and then we have, sorry, I apologize. I just posted the lecture notes. So if you go to your Canvas and then either you go to files, the files is actually more reliable. Because if I upload a new one, sometimes I forget to update the module, so it's not automatic. So today's lecture note is on files. The file that I post before and after lectures will be different. Before lectures, there will not be answer to the iClicker questions. After lectures, all the typos that you point out during lecture will be, so I need to correct the lecture notes and upload a new one. Another way to access that is go to modules. And this one will link to YouTube. So you need to open in Safari, which I'm not gonna do, because you will see other videos that I watch. Oh, this one, yeah, so lecture 3 is already up there. Good. Any questions so far? No questions. So you guys need to be more active. You know, I've been in universities for so long, starting from Washington State, Caltech, Michigan, Harvard, and here. I know that I've been sitting in many lectures, and most of them are boring. So in order for you to survive your undergrads, sometimes you need to be in sync with the presenter. So you need to finish my sentence. So let's say I get electrocuted by lightning, you can still understand the material because you know what I'm about to say. Next organization, and then next lectures will be more, we will spend less time with in announcement. So some of you asked me about the math. This is not calculus-based math. So if you want to challenge yourself, you should consider switching courses to physics for engineers or for majors, but we still expect you to know some math. For example, you need to know vectors. There are things that you should know cold, right? Your social security, your birthday, you can look it up on your, I don't know, Facebook or database. But sine, cosine, you have to know it cold. Vectors, you know, what is a vector? What is a vector? Vector is a quantity that has magnitude and direction. So you should know that. You should know how to add vectors, for example. And if you're not sure, so if this is vector A, vector B, this is A plus B. Right? If you're not sure, then you should ask your TA and LAs or stop by my office hours. We will help you. Trigonometry, and we will talk about unit vectors later today. So in many universities, the way people structure this type of class is that the lecture is just the lecture, so no demo. Like today. Today there is no demo because we are behind, not because I adhere to this philosophy. But I'm just telling you in other universities that I also respect. And then recitation is when you practice problems. This is why it's required in this class, because that's when you practice more and more problems, not in the class. We will do some, of course, but not as much as in the recitation. And then all the demos will be hands-on in the lab, okay? But for you, I will try to do some problem-solving activities and some demo. This is why we are behind. Okay, any question? Okay. Your chairs are numbered, so I can call the position. All right, so let's recap. This is not from last lecture. What are the types of materials based on their electrical conductivity? There are how many types? This is not iClicker, by the way. Just anyone wants to help me? 3? Yeah, what is 1? Conductor. Second, semiconductor, insulator. So it's important. So I promise that I will teach you knowledge that you can use in your daily lives. So let's say you want to change light bulb, or I ask you to change a light bulb, right? And there are 2 ladders. One is made of copper, the other made of wood. Which one that you prefer? Wood, and then anyone says copper? Can you help me? The one that just said this. Why? Why wood is better? So unless you have other purpose than changing the light bulb, you know, you shouldn't use copper. But if you want to dance or something, use copper. So, okay, maybe you are the one who helped me. Yeah. Yeah, so the electricity will flow if you step on a conductor. But if your ladder is wood, unless it's a wet wood, wet ladder, then you should be fine. Okay? So these are the things that we try to teach you. Okay? And then today we will talk about induction. We haven't talked about how objects get charged last time. So the first one is, the name is triboelectric effect. And this is from your perusal on Wednesday. Tribo, any Greek in the room? Stephanopoulos or no? I think some of you probably took a class from Stephanopoulos. My office is right next to his office. So tribo is basically rubbing. So when I was an undergrad, when I was your age, many years ago, more than 20 years ago, my first paper was on tribology. So friction is really important. US economy lost a lot of, I guess, productivity due to friction. In the past, most hard drives were mechanical, so some of them fail frequently because of friction. So one way to think about tribology, or not tribology, triboelectric effect is transfer of electricity because of friction between two objects. There could be something as close as like the comb that I used on Wednesday and my hair. So basically it removes electron from one side to the other side to something as massive as clouds. So clouds can rub each other and build charges, and then that leads to the formation of lightning. Okay. So there is so in your notes, there are many links. I already opened the link. So we face this issue in the US, not in Indonesia, because Indonesia is really humid. That's where I grew up. Why there is no sound? Sound. Oh. Let's just use my computer speaker. So let's reset. So the reason why we get electricity when we touch a doorknob is because your feet rub, let's say, a carpet and build charges. So when you touch the doorknob, you get static. That's what we call static. Okay. Any questions? So you can do this all day. The name is John Travoltage. Second is, this is basically what we did last time. And this also involves polarization, which we will discuss soon. So let's return back to the lecture notes. The link is here. And then based on the material, you can either transfer electron or grab electron from the other material. And the name is triboelectric series. I will not question you about triboelectric series on the exam. Don't worry, you don't need to memorize this. This is just for your knowledge. Okay. The second one is induction. So anyone knows what is the difference between triboelectric effect and induction? Let's try to do this fast because we are behind. So induction, so triboelectric, you have to rub two objects, or friction between two objects. But induction is, you have to, all it requires is a direct mechanical contact. So let's say there is, this one has, I don't know, 1 coulomb, let's say, or 1 electron. 1 electron is kind of extreme. Or let's say 1 coulomb. And then you bring another object. So this is T equal to before 0. And then T, you touch sphere of equal size. Then as T approaches, no, it's actually, it doesn't require even a second. But when you wait long enough, it will be, there is charge transfer between two objects. Okay. So when you touch sphere to another sphere, was charged. The charge moved from sphere 1 to sphere 2. So let's say sphere 2 initially has 0 coulomb. Okay. And then you can even separate the two. And then the charge stays like this. So this is induction. I think the figure in your book that I just copy and paste for my slide is a bit confusing. So I'm going to assign this iClicker question, multiple choice. So there are 3 identical spheres, A, B, and C. A, B, and C. C is not coulomb, by the way. A, B, and C. Okay. Sphere A has charge plus E. Basically, a single. This is a bad. So E is not 1 proton or electron, just a constant. B and C is uncharged initially, so T equal to 0. Sphere, okay. Sphere A touch first to sphere B. Okay. A and B. And then separately, and then separately to ball C. Okay. And then they separate. And then to ball C like this. Okay. At the end of this experiment, the charge left on ball A is, so I'm going to assign this. So 1 minute. Okay. And you can work with your neighbor if you want, because we will not do 2 steps because we are behind in our lecture. All right, 20 more seconds. Ten more seconds. If you're not sure, you can put any, either A, B, or C. 5, 3, 2, 1. Okay. I think most of you got it right. So basically here, you get at this step, A and B has equal charge, right? C still 0, and then you separate the 2. And then when A touches C, it will divide the charge by factor of 2 again. So you get E times 1/2 times 1/2. Okay, good job. It's really good. 92%. Any question? Very easy. Makes me want to make the class more difficult. It's a sign of respect, right? You should be upset if I make it easy. That means I don't think you know how to do anything. All right, so this is the picture in your book, basically the same thing. Here, the direct contact is between the ground. So what is this? It's a metal sphere with an insulator, conductor and insulator. And then there is a charge nearby. But the induction step is the wire and the ground. So what is ground? Anyone knows what we mean or what the book means by ground? Like this is ground. What is ground? Electrical ground. When somebody say electrical ground, it's like basically infinite reservoir, infinite conductor. You can view it like an ocean. You may buy all salt from Fry's, you pour it on ocean, it will not change the salinity or the salt concentration of ocean, right? Similarly, these 4 charges, when it transfer to the ground, it doesn't change the charge, total charge of the ground. So that's the induction in this figure, which I think is fairly confusing. But basically, the difference between induction and triboelectric effect is one of them requires friction or tribology. So triboelectric requires tribology, and the other one requires just touching, direct contact, like a wire like this. Should we do this or should we skip this? Do you want to do it? This is more just like English conceptual question. We can do it for a minute. Again, if your answer is wrong, you get 3 points. If your answer is correct, you get 4 points. So nothing depends on this pretty much, right? Your salary, your future, your diploma. So don't get stressed out by iClicker. Okay, so the question is, based on this picture, if you want to charge a metal ball on an insulating stand, so the stand here is an insulator, using induction, which of the following happens? So you need to read all these options. So I will give you, let's say, a minute and a half. And you can work with your friends, but this is, you have to read the options properly. Oh, done? Okay, sorry. So let's see. Good. So the answer is A. Sorry, I should have give a 3-second warning. Same announcement, not announcement, same rule. You only need to get 90% of iClicker to get 100%. Okay? So if you have to go for, I don't know, conference or anything, don't worry about it. And most of your grades will be your exams. All right, so basically, after induction, we can just focus the last figure. The charge of the sphere changes, right, from neutral to positively charged. And the insulator, because the electron is tightly bound to insulators, stays the same. The charge still the same. The charge of the insulator stays the same, or the rod still stays the same. Okay. Good. Any question? Yeah. Oh, yeah, maybe the figure, the sentence doesn't say that, but the figure says that. So maybe the figure is too small. Okay. Yeah.
And for the question, I thought it was talking about the negative charge rod, not the insulating stand. It just says rod.
Oh yeah, this is the rod.
Yeah, you certainly wrote that right.
Yeah. Okay, cool. Maybe the problem is poorly written. So, okay, fine. I'll give everyone full credit. Okay, but the correct answer to me, based on my broken English, is A, okay? And then because of lecture and we are behind, watch Fundagraph generator demo. The one, so this is ASU, this was made behind the scene, behind the this class. But the one in Prusal is also good. That was from my old school in Pasadena. They have more toys that you can watch. And if you have any video that you'd like to recommend, you can send it to me, and I may assign it as optional assignments. For example, this one. This is the one that you should check out. Not only we are running out of time, not running out of time, we are behind, but those people are professionals. They have done the experiments for years. Another important thing that you should know is about lighting. I'm sure you remember from your reading in Prusal, basically using by triboelectric effect, charges can build on clouds. And then if the density of charges is beyond the limits, the charge would travel to basically to the ground. Basically, those charges need to escape. So similarly here, this is a toy that you can buy from Amazon. I think we bought this for $15. You can make lightning. And if you're like my postdoc, my students, they like to put their finger here. They say it doesn't hurt. But but maybe next time I'll put my finger close to that thing. So what you need to do is, find shelter. Those are common things that you learn when you were a Boy Scout or Girl Scouts. So lightning, one of the most fun, most fun demonstrations of lightning. If you are in Boston, or if you are as lucky as my family, we live in Boston when I was at Harvard, and their libraries have a free museum pass. So that's my weekend activities. Just go to free museums, and one of them is Boston Museum of Science, and it has a famous lightning show. You should check it out. And the video is here. You can watch the video yourself. Okay, or I can play the video before the class next on Friday. Okay, or before in the beginning of the recorded lecture. Any question? Anyone is anyone in an aviation major? Oh, you. How many? Just one? Oh, you must hate me right now because I lecture for mostly for pre-meds. But this is the only slide that touch your field, unfortunately. I have to be fully transparent. This class is mostly for pre-meds and biochem majors. So Derek, right? No, what is your name? Just sorry. Yeah. Do you know how many times flight get hit by lightning every year, roughly? No. Could be less than 100, but around that number, maybe 80 times. And the airplane is designed with that thing in mind. So it doesn't, I think only from time to time you read on the internet that the airplane has to be grounded. Is very rare. So typically when lightning hits, this is basically electrons hits airplane, it equilibrate, meaning it spreads uniformly, and it's still too much and then escape immediately. And I think in this video, you can see a lot of airplanes get struck by lightning. All right. And then finally for electrical transfer of electricity, last time we did demo with comb and papers. and you read this on perusal, the reason why comb can attract papers, like small sheets of paper, is because of polarization. And there is a demo here. So we have, in this demo, we have a neutral balloon, and then you can make it not neutral. Either you do friction with your hair or to your sweatshirt. And then initially, if the wall is neutral, but because electron can move, the electron, because of repulsion between, I don't think I can point, repulsion between negatively charged yellow balloons and wall, this electron here move. And then the wall becomes polarized, becomes slightly positive. So the local region of the wall is slightly positive. And then if you play with a balloon, the balloon will stick to the wall. Okay. All right, so next, I'm going to lecture on what I really want to lecture in the beginning of this class, which is Coulomb's law. Okay. So Coulomb's law, we wrote it last week. No, not last week. On Wednesday, the magnitude of Coulomb's law. So Coulomb's law. And I'm gonna be nice to you. I'm not gonna ask you to discover or develop Coulomb's law. So Mr. Coulomb came up with this formulation, which is K times Q1, Q2. So I'm just gonna take the magnitude time divided by the distance between these two, okay, R squared. So last time I forget the square. So if I made a mistake, you should raise your hand and correct me. I will be grateful. Because what happened after this class is I watch my video and I see the typo. There is nothing that I can do. So R is defined as, this is charge 1, charge 2. R is defined as the center, the distance between the center of masses of charge, like object 1 and object 2. Okay. So let's say you have 2 protons here and 1 protons here. What is R? Where should we put R if we have 2 protons here? In the middle, yeah. So basically, I mean, there is a way to calculate it. You do this F1 and F2, but because proton is very small, especially if you look at protons from far away, then it appears like a small charge or a small objects. Okay. So this is an example. So one thing that I mentioned last time is that it's good to understand an equation. It's good to know how to measure, or like how did people figure that thing out? Okay. So first, how did people figure this R square? How did people figure out that the force is inversely proportional to R squared? Oh, you raise your hand. Okay, thank you.
So as the charges get further away from each other, there's going to be less force. But
Yeah.
as they get closer,
Yeah, for example, you can put objects and you can, let's say, mount one of them, and you can apply springs. And we know that using Hooke's law, oh, this one in recording will be covered. Hooke's law says that the spring is, the force that spring generates is proportional to delta x, but here Newton is famous for 1/r². But anyway, this is how to measure it. You mount one of them, fix the distance and measure the displacement. And then you bring this one closer, the spring also closer, and you measure the force. So what I'm trying to say is sometimes you don't need to know Q1 and Q2, and you can still convince yourself that the formula is correct. Any other interesting thing from this formula? We are really lucky because this is a factor of 2, meaning the exponent is 2.000 until like infinity, basically. There is no reason why it has to be 2, right? It can be 2, 1, 7, I don't know, something like that. But it's exactly 2. So that's interesting. How to figure out that the force is proportional to Q? Let's say Q1 or Q2. Realize that 1 and 2 is up to you. It's a free country. You can say this is 1, this is 2. You can say this is 2, this is 1. So one way to do that using the same technique that we calculated for the iClicker, which is you start with several spheres, you charge one of them using, let's say, triboelectric, and then you can vary the charge, let's say Q1, by touching Q1 with identical sphere. That's how you vary Q. Because in the past, when Mr. Coulomb developed this, so Newton developed a gravitational law, well, basically equation. At the time, he didn't know about charges, but Coulomb should know about that. But anyway, placing exactly, I don't know, 10 electrons at that time was very difficult. Even nowadays, it's extremely difficult. Okay. What else? Is there any interesting thing about this equation? I've been teaching this class, so I'm really good in waiting. So using this equation, right? So remember last time, let's say, I don't know, I'm not good in chemistry. Let's say there are 2 protons here and 1 neutron. What is the symbol of neutron? I don't know. Right. The question is, so some of you may ask me or will ask me, I got a lot of great questions from you already. How can these 2 protons are stable? How can they be stable in a nucleus if they are very close? Because as R approaches to 0, the repulsion force will approach infinity. Then there's no atom other than hydrogen, maybe. Anyone knows the answer? Some of you asked me excellent questions by email. You just need to ask that in class. Yeah. The question is, if there are more than one positive charge in nucleus, how can those charges be stable in a nucleus? Because they are very close to each other. They are within 10 to the 15th meter or 1 femtometer. Yeah. Yeah, so there is a nuclear force that we briefly mentioned, strong nuclear force that we mentioned on Wednesday. So yeah, so basically for very short distance, there is another term that has a constant and it has exponential decay. Some are not and R square. If this constant is large, if R is really small, then this term dominates. But if R is, sorry, if R is very small, like femtometer, R is on the order of femtometer, then the second term is dominant. But if R is weak, no, not weak, if R is this distance here is about the size of nuclear atoms, then the Coulombic interaction will be dominant. Okay. What else? There are many interesting. If you for your exam, you just need to know this. But it's actually, it has a lot of non-trivial consequence. Some of you want me to talk more about biological relevance. So one biological relevance is DNA. So DNA has the backbone of DNA is, okay, first DNA is right-handed helix. And second, every base pairs, ATCG, it has 2 negative charges. And another base pair, it has another 2 negative charges. Okay. Using Coulombic repulsion or Coulomb's law, the diameter of DNA is 2 nanometer. And all of you know this, that 2 nanometer is very small. The question is, how can DNA form if Coulomb's law is right? Not you. Sorry. Yeah. One with same sweater. Yeah. If DNA has a lot of negative charges, how can DNA even be stable at all? Really nice. Positive charges where? In what? Phosphate is actually negative charges. But I know you can think, finish your sentence. It requires positive charges. That's a really excellent insight. Where can we bring positive charges? So, okay, anyone, maybe you with a bicycle? What? The basis in the middle is mostly due to hydrogen bonding. And the reason why they stack is because of pi-pi interaction or dipole-dipole interaction. Maybe, I think many of you have taken organic chem, right? So the reason why DNA is stable, and you can, if you belong to a lab, you can test this yourself. In order DNA to be stable, you have to put a lot of positive charges. The one that we like using is magnesium, because the valency is 2 instead of 1. Instead of like sodium is only 1. So you can run, if you run most biological experiments other than measuring the concentration, like absorbance, if you don't put magnesium, let's say you want to clone a gene or you want to study, I don't know, the activity of EcoR1 enzymes, if you just run it in water, you just waste your time and reagents because the proteins will just, so without magnesium, the DNA will denature, will dissociate into 2 strands because all of these are negative charges. But if you add magnesium, then it will form DNA. Of course, the base pairs have to match. Okay. 6 more minutes. All right. So this is what we have discussed. One thing that I haven't mentioned is what is K here. It has something to do with the property of vacuum. So right now we calculate, let's erase the strong nuclear force here. We calculate the force in vacuum. So it's 1/4 pi epsilon naught, which is the permittivity of vacuum. For you, if you want to solve the problem, you can just use K is close to 9 times 10 to the 9. You don't need more than 1 digit for this class, for K, because it's very close to 0. Any questions? Good. So another nice thing is that the force are equal, but opposite direction, always opposite direction between two charges. So if you still remember from Newton's law, the last one, the third one is what? Action is equal to reaction. If one body exerts force to another body, then the force will be equal, but they have opposite directions. And one thing that I skipped because I forgot, because it's obvious for many of you, if the sign of the charges is the same, then you will have repulsion between two charges. If the signs of two charges are the opposite or different, there are only minus, plus, and perhaps 0. Then you get attraction between forces. We will not do iClicker, but please do iClicker when you watch the video. So I'm going to ask you to pause. Just pause, because it's fairly straightforward. So last is, I have 4 more minutes. What happens if we have more than 1 charges, or more than 2 charges? Okay. So there is a principle that you already learned last semester with sand. Basically, you need to, the name of the principle is superposition. Basically, the sum, let's say we want to focus on the force that Q3 experience. So if we have these 3 charges, we will get repulsion between Q1 and Q3, but attraction between Q3 and Q2 because the signs are different. And you can figure out the magnitude using F, using this Coulomb's law. And now you need to figure out the direction. The direction, because force is a vector, right? I don't remember the symbol that your book used, but I'm just gonna use R hat, and I'm gonna change that. I'm gonna make sure that the symbol is correct before I upload the post-lecture lecture notes. So this is what we call, what do we call this? R hat. Or some textbook use ER. What is this R hat? Okay, so R hat is, we call this unit vector. Okay. What is a unit vector? What is a unit? Let's say I buy a dozen of eggs. Well, dozen of eggs is 12 actually. So the weight of this object is 5 kilograms. What is a unit? Yeah, 5 kilograms, right? So the kilogram is the unit. So this one is actually has 1. Well, no one has ever said that, but for this discussion, it is as if there is 1 in front of it. So it's a unit value. So the unit is 1 kilogram. So the unit vector, it has magnitude of 1. So the total magnitude is still the same, but it tells us the direction of the force. It's basically a way to tell us, to tell your readers or mastering physics that there is a direction. And then you need to review vector addition. If you're not comfortable, ask your TA and LAs to go through it in your recitation. Any questions? If not, enjoy your long weekend. I'll see you next Friday.